we're talking about the typical use cases on a big data. Okay, so what are the different use cases and how big data is really useful to make a certain decisions on certain analytical decision for different kind of enterprises, right? So we have scenarios into different domains, okay, and we will be looking into some of the examples in each of the domains. We'll start with a web or a e-tailing kind of a retail kind of a scenario, and then we'll go into certain other scenarios on the telecommunications sector, and then we'll have some government sectors and healthcare and life sciences. Okay. So before I start with, can you guys let me know you are from which domain so that we could talk in specific to that domain?
Vivek, I am from actually healthcare domain, health
Okay.
insurance and property and casualty insurance.
Okay.
Mhm.
Healthcare. Okay.
Yes. So, but we deal all the other domains also as
Okay.
a tester and as a business analyst. But mainly
Oh.
these two domains we will work.
Okay. Okay. Fine. Okay. How about you, Venu?
Currently working on retail domain and previously worked on the insurance and banking domains.
Okay. Okay. Right. Right. Okay. So, yeah. So what we will see is pertaining to your use cases. Okay. So we will take a couple of, let's start with the use cases on healthcare and life sciences. Okay. Before we go into any other use cases. Okay. So typical use cases, if you can see in a big data, okay, they vary, they record the large or enormous amount of data, okay, and they process that data, they analyze that data to make a certain decision, okay. So very first example, if you can see, is on a website or a e-tailing, right? So if you remember, if you go to any of the website like Amazon or a Flipkart, okay, there is something, if you buy out certain products, okay, if you say, suppose if you have bought a mobile, okay, and next time you visit or immediately based on your buying pattern, there would be certain set of recommended products that website will be throwing it to you, okay. If you have bought a mobile, it will immediately tell you that if you want to buy a case for a mobile or if you want to buy a charger or anything, right? There are certain products which are pre-packaged, okay, and based on that pattern, that immediately it will analyze your data that you have done this, and then it will start recommending those products. Have you guys seen all of this? Okay, if you go to a movie, Netflix, or if you go to any website like Flipkart, Amazon, have you seen the recommended products?
Yes.
Okay, right. So this is the one of the typical use cases which is very, very important because customer would like to buy. It is basically increase in revenue for the company, right? If you start recommending the right set of products, okay, for your organization, in that case, what will happen is people will tend to buy more, and that will have an impact on your revenue. Okay, that will basically increase your revenue, right? The second thing is on the ad targeting. Okay, so ad targeting is another thing which is very, very common because if you just see if you just go to Facebook or if you go to any Google AdWords, okay, and you start showing out certain you wanted to show the ads to the specific set of people, okay, maybe the people are more from say for example you have done Hadoop testing course, okay, just on the Google, right? And if you immediately see there are certain set of recommended or certain set of ads which are targeted, okay, so you go and search for Hadoop training and it will show you the list of trainers or list of people who are providing trainings, okay. Similarly, if you go to any website, okay, you start seeing a certain kind of ad patterns on those websites based on your information which the website captures. It will start showing you the ad. The third thing is the social networking website like Facebook and all. On the right hand side, have you seen ads? when you log in into a Facebook account,
Yes, sir.
Yes.
right? So those ads are more targeted, right? So those whatever based on your information, if you have shared on the Facebook, say for example, you shared on the Facebook that I'm going to get married, right? Or for the marriage, right? So immediately that data would get analyzed, okay, and it starts throwing you an ads that if you are going for a marriage or if you have updated something on a marriage, it will start showing you an ad specific to if you want to buy certain gifts for the marriage, okay, or the dresses for the marriage, okay, whatever it can be, n number of things. So based on what you have written, they will try to analyze that data and start throwing you the ads, okay, or the targeted ads, very precisely to say that, okay, and those ads are very much targeted, okay, and those ads are very specific for what you need, and it can have a very commercial impact or the revenue impact on the website, okay. So also if you can see, sometimes if you go to Amazon or if you go to any other website and you just search for a product, okay, suppose on Amazon you wanted to buy a hard disk, okay, and you search for the hard disk, okay, and for some reason what you did, you never bought that hard disk, okay, and immediately you came to the Facebook, okay, and you started updating your status. The data, you will see the recommended ads, okay, or the ads which are targeted, right? It will be showing you that Amazon is selling this hard disk and this is what the rates and so on and so forth. You will get ads which are targeted for you because of your buying pattern, what you have done on another website. So this is more ad targeted, okay, and if you want to try it out, you can try it out on your own also, and if you will see there is a lot of sense in what you do activity on the internet and what you see on the different website, okay. So all of this are targeted to increase the revenue in this industry. Okay. The third is the search quality, right? So if you are doing for a search, okay, or the quality of the search, if you are doing in any of the websites, say for example you are searching for a pizza, okay. So what kind of information you would like to see on the top 10 results which Google shows, okay? It is based on certain algorithm, okay, that algorithm is based on the data what people have done in the past, how they have if they have searched for the pizza, 90% of the people have might have clicked on the link that where to eat pizza or the nearest location to where to eat pizza. Only 10% of the people, when they search for a pizza, okay, they have gone for how to make pizza, okay. So based on all this information, okay, so out of your customers, okay, out of the 100 customers, okay, 90% of your customers are interested in eating pizza, okay, when they are searching, okay, and only 10% of the people, okay, are really interested in how to make pizza, right? And based on all of this, right, so basically you would like to see the more page rankings or the page coming at the top showing you the and pages which will be showing you this information, right? So if you can go to the Google and then do a finding this pattern based on the algorithm and the data collected over a period of time based on the use. The another thing is abuse and click fraud detection. Okay, so what is the abuse and the click fraud detection? Okay, so if you can say for example you are a user, okay, you are a user who is accessing a website or a bank website, right? Right, okay, you are a genuine user, login to do certain transaction, okay, to take a money or to transfer a money or whatever you wanted to do on the website, okay, right? There are users which are not genuine user, or they might be trying to intrude into your system, okay, or they might want to attack the system, okay. Right, so how do you make a difference? Okay, so this website has to make a capability or have a capability inbuilt so that it can serve the genuine user, but if the request is coming from intruders, it should be able to basically block the IP address of those intruders so that the denial of the service cannot happen, okay. So denial of the service is say for example my web service is I hope you guys knows denial of service. Anybody knows what is denial of service?
Rejecting the service or blocking.
Okay. So see, denial of the services in terms of when we are discussing about the web application, right? So web application or the web server is designed to serve certain number of requests, right? And this certain number of requests is based on so many factors, right? So basically, if you're using any of the web servers, say for example, I'm using my web server IIS, okay? So this web server is basically serving number of requests, and this request may be on multiple factors, okay? And this multiple factors, one of the factor can be a RAM, okay? The another factor can be a CPU, okay? That is more in the hardware terms. In the software terms, it will be basically the number of bytes which this server can serve, okay, based on whatever configuration you define it, right? Okay. So what happens if the request is coming more, okay, from this user, okay? So whenever it is there are intruders into the system, what will happen? Intruders will try to break into the system, okay, and they will try to, right. So what they will try to do, basically they will try to send multiple requests to my IIS server, okay, and this request would be more specific, okay, and to onto a certain page. Maybe it can be only on a login page, okay, or it can be only on a single page because they want to break into the system with certain username and password, right? And they would try to do multiple combination of username and password to hack into the system, right? So what happens is that the server everything is getting logged, okay? So IIS server or any servers, okay, this servers has a logging capability, right? So this logs, right, and this log will see, okay, in the log the information that from this IP address, okay. So log typically looks something like this, okay. It will have one IP address, okay, and then it will have a URI, okay, basically the request which is coming, okay. Then there will be something called bytes sent, okay, and bytes received, okay. There may be multiple fields, okay, but I'm talking about a typical set of fields, okay, into any log or any web server logs, or for our case we'll just consider the IIS logs, right? Okay. So what will happen? Everything will be get logged into the IIS logging. Okay. And what do you need? Okay, this logs over a period of time through the multiple users who are trying to access the system. Okay, this logs might get considerably large. Okay, and this log you want to do the analysis on a runtime basis. Okay, or maybe a quick analysis you wanted to do. Okay, so that you identify that multiple requests are coming from this servers. Okay, which are not genuine server, okay, or which are not genuine requests, okay, and you would like to take a quick decision, okay, based on the data what you have analyzed. You would like to basically block this IP, right? Like to do in this case, right? So all a very huge data set and so on and so forth, okay. So this is a typical big data used trying to do the abuse, okay, just to avoid the denial of the service attack, right? Are you guys with me till now? Okay. So, what the other typical use case? Okay. So, before you joined in little late, I wanted to know from which domain you are or which domain you're primary. Okay, HRMS. Okay, okay. So HRMS is one of my favorite domain. Okay. So, right. I was part of Sum Total in the past, so I know that HRMS. Okay. Right. So the other typical case, let's take a case in the telecom sector, right? So what is the telecom sector and how the big data can be useful over here? Okay. So there is something customer churn prevention. Okay. So if you have seen, okay, there are multiple service provider for in the sector, and people would like to retain the customer, right? So basically, nobody would like to lose the customer because it is a direct impact on the revenue, right? So what does it happen? Say for example, you have having a very good user base, okay, and you typically see over a period of time that customers are trying to move out of your network. Okay, they are This customer was somewhere very premium customers, okay, and this premium customer, right, they have gone out of your service and they have gone to some other services provider, okay. Now you your network and why they are taking the another network, okay. So you would like to analyze the pattern, okay. So analyze the pattern over a period of 1 month or 2 months, how they have used your services, okay. So maybe this user is basically located in, say for example, Karnataka, okay, and couple of weeks, okay, certain location, okay, and this location may be location in, uh, and what you have seen, okay, after coming back from OT, so do you really see it, right, or at least you can deduce some pattern, right? So what pattern we can deduce over here is, okay, this guy went to Uti, okay, and from coming back from there, he immediately changed the changed the network provider. So what might be the causes is maybe he went to Uti, he didn't find the right signal, okay, might be your coverage so good over there, okay, might be he is not able to make calls to very important calls, okay, to the network for his business needs and so on and so forth, right? So you can deduce that. You can, and if you see multiple people are having this issues, okay, maybe you will not like to take an action based on one or two users, okay. Maybe those users itself are basically who are not paying the rentals properly and they want to shift to the another service provider, okay. So this, but over a period of time, if you would like to see the data, okay, of a multiple user, basically in a custom in a telecom sector, you have millions of customers, right? So maybe millions of a customers, and now you suddenly see a pattern, okay, and you see, okay, most of the users, whenever they move to a certain location, okay, wherever your network is not there, okay, they immediately switch to another network, okay. So maybe you would like to do certain kind of analysis and see, okay, is it more why if the other service providers are already available over here, if you're not available, you would like to invest out something over here, okay, and this will prevent your customer churn that is happening because of that. The another thing is network performance optimization, right? You would basically would like to optimize your network, okay. So in the similar case, if there are not a, you like to put your own network, right, or you would like to do a shared network, whatever it is, right? So you would not like to have your own network, right? So what will happen is that, right? So you would like to see that how the network can be properly utilized, or optimum utilization of the network can happen, right? So let's take a typical case during the Diwali season, okay? So during the Diwali season, suddenly there is a, not nowadays, okay, but in previous, the network, when we used to send SMS and all, okay, there was a sudden load increase, okay, on your network, able to only serve certain and X number of requests, right? So X number of requests it could serve, right? But with season and all, there is a right, and your network is really not capable. Maybe it has increased to 3x times, right? You are not able to sustain it, okay, and then you had a total network breakdown, okay. So what you can do over here in this kind of rates during the Diwali season, okay, so that your revenue, okay, and the rates during the Diwali and during the normal definitely would not, okay. You would also provide a lot of free services during this festival season, right? So all of these things you can do analysis with the data. First, you need to have it, okay, to understand the pattern. Okay, if you see a sudden surge, okay, so if you see a certain kind of a surge during the season, so normally this is your rate of SMS, and the rate of, there is something really wrong over here. Okay, what causes this surge into the number of SMSs, right? You would definitely like to do certain analysis, and that is where you can use your data. Big data analysis is very useful, okay. Then you can do a call data record analysis for certain purpose, okay. You can make certain decision based on that, and even if you can do a network prediction failure in that case, okay. So I have covered here, and then other set of use cases are, you can, a lot of use cases are defined which you can go through to understand that, okay. There are government sector and health sciences, okay, healthcare and side, okay. So there is it's a very important use basically on the gene predictions, okay. So similarly, like you do a prediction, there is something which you can do based on the gen predictions, okay. are based on a data set which is normally which is being captured with what is their gene, how this, okay, what is the in a certain individual, and then you, if you have a small child or a small baby, put to this there is something called, okay, this genome patri is basically will help you to see if your genes are matching to certain visual, okay, and make your child align to certain games, okay, where he has more, right. So this is based on a typical match which has, okay, and then they do a prediction which is more or less accurate, so that in your child sports, okay, where he could excel, okay, where he could get a success. So this is one of the use cases which is used in the healthcare and the life sciences. Another use cases is basically, say for example, you have a history of all your we medical records, okay, organized with us, or they're not organized at all, okay. You might have a data over a period of 1 month or 2 months, okay, that is the latest, whatever, wherever you have gone very recently, right. But if there is a way to capture all the health records, okay, from your childhood, okay, from your childhood, so there is an entire, right, and okay, what immunization you have taken, right, what allergies you have, right? You have all of this information, okay, with your provider service which he has, okay. The moment you add, I am having so and so disease, set of records, historical records, and his more allergic chance or the certain anti. Based on that, he could make a better prediction on your actions for you, okay, and so that you would not you'll have a better chance of okay, base data, right. So this is a very important, right, and this makes the task of a medical officer much easier, as well as it will have a much faster rate of cure for you, right. Right. So this is what the drug safety and all we are talking about. Which drug. So there are other use cases. We will not go through the banks and the retail anyway. I will go into the certain. I have certain slides on. Okay. So the limitations of the traditional big data, because a shift has happened. Okay, from the, because the data, right, the processing of the for the analysis purpose to different stack, and this will not be possible. We will see possible with the traditional technologies, right, and why there is a need for a solution. So these are the I would say a typical flow in for analysis process. Okay, okay, it will be clearer to you, but in detail background, it is just a move from your data over here. Okay, so my data is available over here. There can be multiple. Okay, and right now what I'm talking about is, right. So I'm pushing all of this data into my slide. So this data has to be analyzed. Okay, analysis is basically a ETL process where you do a transformation, you do certain processing, right, of the data, which is after you process your data, you would like to reports, dashboard kind of a situation where you see, okay, this is what the visualization of a data. So this is a typical flow into a data warehouse, right. And this storage right now is a central normally happening on a single machine, okay, and the okay, where you can and then show all your reports, right. And so there are all of this layer, okay. We will talk about this, we will look into the challenge, okay. So are you guys good at this? So are you
Yeah, can you please repeat it?
okay? So Selvan is good with this slide, so I'll just repeat it for you, okay. So see, as I mentioned, okay, so let's take an example of HRMS, okay. Okay, let's take this example. So HRMS system consists of multiple subsystems, right? You might have a system for learning of your employees, right? Then you might have a system for talent, and you basically would like ration, right? You the performance, right? So this is another application, right? Performance, right? And then you might have a certain, right? So where you have a application into an HRMS system, right? Do you basically a separate application or separate OLT, okay, and they will, when I say a separate OLTP system, right, they will have their own set of web app, right, okay, right, they will have their own set of databases. Now you would like to see the holistic view of your data, right. So say for example you would like to see a employee, okay, say for example I wanted to E1, okay, what was his rating last year, okay, what training he has done, okay, what training or learning he has done, okay, what is his typical typical talents, okay, or basically what is his profile information, okay, what all skills he knows, okay, etc. Right. Now all of this, okay, rating is coming from your performance somewhere lying here, or learning is coming from this system, okay, and skills are coming here, okay. This is my talent. Never be in a position to see this data, okay. If I have to hit my so what I would like central storing, okay. I like to process my data so that I have a view basically aware of dimension so I would like to see employees my dimensions and then facts, okay. So I need to this processing and then finally I would this is right. So I cannot data. What I would see typical reporting so that the reports this is accessible through my web URL, right? And then I go to this or employees based on certain geographies, which we have now here, right? So this is so let's talk about the storage challenges, right? So I talked about a very plain example of HRMS and then moving the data, right? So what are the challenges with the storage data? Okay, so data is coming. So I have this OLTP system, okay, and right, I might have certain data which is coming at from and some of the logs, right? Okay, or the social networking website. Maybe you would like to capture the talent information from the LinkedIn, okay, social of logs and all, right? So all of this data is from multiple, right? Now you get into a single, and then you need to process. So what happens when you move this data? Okay, you typically would need a storage. This has to be high-end storage, okay, and when you have saying the high-end storage, and this is a single storage, okay, you would basically would like to have a certain capability for a failover, right? Because you would really would not like to, okay, and machine and if mechanism, okay, I failover, okay. So failover is a mechanism wherein this even if this machine is down, there is a failover in a separate machine and this data is available, okay, and you would be able to serve all the reports, all the business critical reports, right? So when you are going for a high end, it's just typically very expensive, okay, and you will I don't know have known, okay, but people especially they know the SANs are very storage area networks are very costly, and the high end SANs are very costly, okay. Typically it's thousands of dollars, okay, maybe 10,000s of dollars, okay. What happens over mechanism, okay, so that you don't lose your data, okay. And the third thing is this storage has to have a capability to read and write, right? Basically, whenever you are writing a data or whenever from a disk, okay, the best disk cannot. Okay. So best disk cannot read beyond 100 Mbps per second. Okay. So if you just talk about the hard disk, okay, which is called now we have a SanDisk which is 100 Mbps, not 4000. Okay. So typically in your computer or if you have a desktop at your home, okay, you would prefer to have your operating system on SD and you will have to have your prefer to have your other storage on the HDD, right? The rate at which you can range, right? So if you see this range, okay, 100 Mbps per second, right? Now say for example, data set which is on the size of the data as I was talking about, okay, 1 petabyte. That is what I said, right? 2 to 5 petabytes on a big data. You guys remember this, okay? It is a big data thing, right? Now, if you convert this petabytes of a data, okay, it converts to 1,000 gigabytes of a data, right? Right? And if you just convert it, okay, okay, it is 1,000 TB of a data, right? It's not GB of a. And then if you convert it, it will be 10 raised to power 6, 10 power 6 gigabytes of a data, right? Okay. Now if we convert it to the megabyte of a data, right? So it would be 10 power 9, right? MB of a data. Now, okay, you do a rough calculation, okay, with this rate of speed which is 100 Mbps per second, okay. If you have to read this data, what is the seconds it will, how many seconds it will take? 10 raised to power 7 seconds, right? 10 power 7 seconds. 100 by 10 power 9. So I got this, okay. So if you are wondering how I got this figure, okay, and you guys have lost, okay, so just for terabyte is a 1,000, so 10 raised from that, okay. 10 raised to power 9 comes from 1 gigabyte is equal to 1,000 MB of data, so 10 power 9 comes from that, and if I divide it with this number, which is the rate of speed at which I am reading the data, so in order to read, right, I would like you guys to convert this into minutes, convert it into hours, and let me know what is how long will read 1 petabytes of a data. Okay, you can drop, you can send me on the chat box. You can open all your calculator and send me. Okay, right. So when I am in the meantime, you calculate it. Okay, I would just like to say this thing that this amount of time to read this data, okay, this kind of data set, it is very slow, okay. And if you take this amount of data just to read, okay, think about the processing part. This is just a reading and all, right? So that will take another set of time and all to process this entire data set. So this is the okay. It becomes very expensive. It is too slow, okay. So these are the key challenges, and it's I'm still waiting for an answer, but you. So this is how Hadoop, we will talk about the Hadoop single storage, okay. But here how it tackles, it just remove your centralized storage, okay. So now in place of your central Hadoop storage, okay, it is in a cloud kind of a thing which you can see, and that is what the Hadoop is all about. Okay, we will see all moving from the external system, okay, okay, and once you move this data into the Hadoop, okay, how does it helps in scalability, in the costing, right? Okay, thank you. Right. So we will see this once, just to give you an overview. Okay, so Hadoop will have a multiple systems, okay, or a subsystems where the data would be stored. Okay, this data would all be divided into this systems. Okay, maybe this, okay, maybe this. Right, right. So traditionally, previously when the large scale system were designed, okay, uh, so you might have seen that, okay, that whenever you wanted to have a good processor, or whenever you want to speed up the processing on your machine, okay, you initially 6 MB of a RAM, okay. Right now we are talking in typical shift that has happened to our your personal systems, right? Enterprise system, if you take, okay, if I just take personal systems, right, system would have something, they might have 8 GB, okay, okay, or maybe a 122 or 128 GB of RAM. You guys might have seen the deployment on enterprise system, right? So this would be the typical onto the RAMs. In order to make a system more, like to do in the similar processor, you go from 4, okay, to really a 16 core machine, right? You really don't go beyond that because it generable, okay. Whereas 2 cores, okay, 4 or 8 cores. So what we are talking about is if you have to increase the process, right, you would ability of a system, and it is again on a scaling up, right? Now this has been the traditional system, how the vertical scaling has happened for memory, okay. But again, it has its own go beyond a certain, okay. As I mentioned, you cannot go beyond a certain, can go to 64 GB RAM, but you really can't go beyond, okay. So you really cannot with the vertical scaling of your hardware. Okay. Solution of a distributed came into the picture, right? Saying this is not a single, but what I have multiple systems, right? So distributed system is more about, okay, your entire processing is distributed. So in place of having 164 GB, 132 GB system, another 32 GB RAM system, okay, or maybe I can have 116 GB RAM system, okay, and I can have another 8 GB RAM system, right? So really for a very costly software, this processing with this memory capability, I can go with this, okay, and I can have multiple machine, not the software, multiple machine where I could process my data, okay. But capability of RAMs and all, right, on the core side also, right. So I can have this defined as the 4 cores, right. I'll say 4 cores. This again I can say 4 cores, okay. I can say and 8 cores, right. Thing because we would normally tab less than the so maybe just for the sake, okay. So you'll have this many cores now. When we are talking about 32 cores, now you like this, and you can or the processing part, and that is where the distributed system got evolved can happen. So typically the example of Milky Way and SETI. SETI is the project which you can search on the internet. The extraterrestrial intelligence are sending the data, and people are loan their system, tell them to process the data from to this project which is called SETI, okay. And you can say I want to loan my data, loan my machine for the I can have my machine somewhere available here, okay. And so, but what are the challenges with that? So this really has one challenge, that the storage, though the processing was, but there was a single storage. Single storage was having a deadlock, right? Which if all of this, okay, and the rate is 100 Mbps. What okay? So now if you see, it will take a phenomenon to read the entire thing is you have to over the network. Okay, so when you transfer the network bandwidth is also finite. There will be a blocking, or there would be. Third thing is there is so the costing of the challenges which they did not solve. Again, there was a challenge. Other challenges with system is, say for example, part of my data, right? So part of my data, say for example, I moved. Okay, the part is here, okay, storage, and part, right? So now what happens when you are processing this part, okay, right? And for some reason this machine got crashed. Okay, the way I would know how much of has been processed, okay, into my central. I have to start from where I have from the zeroth position. Okay, so this was the typical programming challenges, and this was all needs to be maintained by the developer, right? So the programming complexity became very high. Okay, the finite bandwidth. Yes, if machine one phase, what will happen? Okay, sophisticated storage, as I was mentioning, will increase for a common solution. Okay, what would be the common solution for that? Okay, so that is where the Hadoop came into the picture, and then how Hadoop solves this problem, we will look into it. 15 more minutes. I would like to continue the session for 10 more minutes. Is it okay with
Yes.
all of? Okay. So I think all are okay to continue for 10-15 minutes. Fine. So how Hadoop solve these problems, we will see, right? So we'll first look at the Wikipedia definition of Hadoop, okay? And I will by line, okay? So it's a library, okay? Software library is a framework, okay? That allows for the, okay? So this distributed processing we are talking about, okay? Across the cluster of computer using a very simple program. So when we are talking about a Hadoop, it is a framework, okay, that is specifically designed for a distributed processing, okay. And what it offers is it can be scaled up from a single machine to the thousands of machines, right? Okay. You can with the commodity hardware, you can have one machine, you can have hundreds of machines, okay, or thousands of machines also, and each offers a local computation storage. Okay, we have just highlighted this local part. Okay, I'll tell you why. Okay, if you remember this figure, okay, my storage was somewhere here, right, and my processing was happening. So I had three processing happening over here and processing happening here, right? Okay, and this was my central storage. Okay, so now what was the challenge? The bandwidth was a challenge. Then you have to read the entire data, and all of this thing was a challenge. But with the Hadoop, right, your storage and your single node, right, and that is what we talk about. So I have a storage. Okay, this is part one of a storage. Okay, the process. Okay, and if I have a different storage, okay, the storage of part 2 and the processing of part 2 will happen here. Okay, so I'll say storage part 2, okay, part 2, okay, will happen here. Okay, so this is what it provides, a local computation. Okay, so you really don't have to use the bandwidth to move the data here and there. Okay, the another important thing is, rather than rely on the hardware to deliver high availability, we talked about the high availability, what will happen if this system goes down. Okay, the library itself is designed to detect and handle failures at the application layer. Okay, so delivering a high available service on top of a cluster which may be prone to failure. That's of a system in the Hadoop cluster. Okay, so when I'm talking about the Hadoop cluster, you would basically talking about 30 node cluster, 50 node cluster, and so on and so forth, right? Right. So all of this will have a multiple system in the cluster. Okay, and it is very common, right, that one of the machine will get failed, right? Either this machine gets failed, or this machine gets failed, okay, or this machine gets failed. Okay, if one of the machine gets failed, okay, your entire processing should not get stopped. You should not see a total shutdown into your system, right? So basically that is what we're talking about, the high availability, right? So system is still available, okay, and it's a high available system. It detects the failure, okay, its own healing capability, right? It basically programmer does not have to worry about in case what will happen, right? So there is there which itself takes care of that. So you about that, okay. So this definition is very on the high level. Once we go into the detail, we will have more clarity on what I'm talking about. But still, I would like to take any questions if you guys have right now. Any questions? Okay. So if you guys have no questions, I'll just proceed. Okay. So I need a response for this for the questions which I have posted earlier. Okay. If I have let's take this thing. Okay. If I have a 1 GB of a data, okay, equivalent to 1000 MB of a data, okay, and the reading is happening at 100 MB. Okay, so how long will it take? Very simple question. I want to answer. If you have this amount of data and if you're reading at this speed, how long will it take?
10 seconds.
Okay, fine. So I have now 1000 GB of a data. How long will it take? Which is equivalent to 1 TB of a data, right? So that is what we are talking about. So 1 TB of a data, how long will it take?
1000.
So if I have to convert it into hours, okay, how long will it take? Okay. So you guys still,
Yeah, 1000 by 60 into 60.
so can somebody tell me the exact hours? Okay. So 60 minutes is equal to 1 hour, right? Hopefully you guys know this. Okay. So I'll give some more time. Okay. Just I'm awaiting the. Okay. You can send me the answer on the chat box. Okay. And I want it in hours, right? System. Okay. So I'll come to this. See. Okay. And if I'm reading this at this capability. Okay. Right. So I got an answer from one of the participants. I'm awaiting from others. Okay. So if I'm reading it at this from this single machine at this capability, but if I'm reading at this speed, okay, normally the time would be 1/6 of what I'm doing that, right? So just take a simple example, okay, or if you have it, so the amount of the take to read the entire data set, it has reduced by 100 times, right? What we were taking with the should be 100 time of the initial time, right? Okay. So roughly it takes like 2.5 hours, okay, and if you not 3.5 but 2.5 it by 100, it would be that. So what we are talking about is a distributed file system is basically dividing your data across multiple systems so that you can scale up your system much faster. TB of a data, so somebody might have calculated this. Just do this math ahead with the Hadoop storage. I think. Okay. So last 5 minutes. Okay, I'll just do that. Okay. So last 5 minutes, I'll try to wrap it up. Okay. So Hadoop storage approach is a radical shift in the approach in which we were having a data storing, right? So whenever you have a data, okay, so what happens is that Hadoop stores this data, divides this data itself, okay, and if this is, say, for example, I have a single file of 100 GB of a file was the host of computer. Maybe you can take a rough math and say, okay, 33 GB will here, okay, again 33 GB will be here, and so on and so forth, right? All of this data would be divided over here, right? So and divided, okay, also replicated, okay. So what does mean by replicated? So if you divide the data and this machine goes down, right? If I have divided this data and this machine goes down, what will happen? I would lose the data, right? And I would not like to lose this data. I would like to see that this data is replicated, right? So that even this machine goes down, okay, I would still be able to serve this 33 GB from machine 1, okay, to be available, because otherwise it will be useful to me, right? Losing the data, and ample machines are bound to get failed. So we really do a replication of a data. Replication is just a copy of a data. Okay, we will see how the replication is done in systematic approach, but just remember the replication of a data is done. Okay, so that, right? So distributed data, when data is stored and then data is also replicated. So these are the two key points of a Hadoop storage, right? Wherever the data is there, okay, the processing will happen on the same node. Okay, so from the previous example, if my data part 1 is available here, okay, the processing happens here, available here, right? So you move the data like this, right? So during the storage itself, during the storage, the data is divided. These are my Hadoop node, my node 1, node and node 4. And then you have your data. There is a master node. We'll talk about it. And storage and processing. So the data is available. The data is split into, I was mentioning during the file of 1 GB and so on and so forth. The data is typically the block size in the Hadoop in the subsequent slides. Okay, right. So I think we will stop here. Okay. And so tomorrow I'll go into more details of the core systems, like I was talking about, and the map reduce. This is the HD HDFS, the interesting part is the MapReduce. Okay, I have 3 more minutes, so I would like to just log in into my cluster. And so once we start, this is important thing to because from tomorrow we will do more of a hands-on also. Okay, not today, right? And did I start the recording? Oh, I didn't install also today, right? So, so what I was saying is, from tomorrow onward, the hands-on would be there. Okay, and today what I will show you is how to start my HDFS cluster. Okay, how to get this VM and all. I'll let you know. Okay. So this is my machine, Ubuntu machine, and this is the terminal. And how do I start my Hadoop is with this command, okay? And when I fire out this, we will talk about this scripts and all later. But when I fire this, you will see a host number of service daemons, okay, in Unix terminology. So these are the daemons which are running. Where so Hadoop itself consists of multiple pillars, right? As I was mentioning. So those services. So tomorrow we'll talk about it in detail to understand this. Okay, doing it. Okay. So just see that it is just logging out. Or I fire this command, J number of daemons which are running are basically the Hadoop daemons. Okay, so if you can see, there are 5 daemons. JPS is just a command. Okay, so you just ignore this. Okay, to see what are the services are running. But these are the daemons related to Hadoop. Node manager, resource manager, name node, data node, and secondary node. We'll talk about the what are the usage and what each is being used for in subsequent sessions. If it's running or not. Okay. So I think I'm done for the. I would like to take any questions if you guys have already extended. Okay. I'm open for questions.
Yeah, Vivek, actually, in a Hadoop processing the data will be divided into blocks or nodes, right? In case if any node is not working, okay, then how the data processing will be done?
Okay. Okay. Fine. So Venu's question was more like if one of the node is down, right? What will happen? Okay. So we'll talk about it in detail in tomorrow's session. But as I was mentioning, if even though if one of the node is down, I talked about the replication, right? So replication is if this node is down, okay? If this node is down, there would be N4, okay? And the same data would be available. So if data is D, okay, which is available over here, the same replicated, okay, dr is, we'll talk about in detail, but to give you an example, the replication is there so that you don't lose the data. Okay? But if 2 nodes have the same data, it is not that the same data would be reprocessed. Okay, the framework is intelligence enough to say only one of replicated data is not processed, only the data which needs to be processed will be processed. Okay, we'll talk about it in detail too, right? But this is just to give you an overview of answer to your questions, Venu. I cannot explain everything now, but the replication will solve the problem, whatever you have asked for. Okay?
Yes.
Okay. Okay. Right. Okay. Yeah, so I think we are all done. Even I have to rush for this thing. Okay. So we'll meet tomorrow. Thank you guys for joining the session. Okay.